So this reference is a concept where it is a it is a variable, it is a keyword variable that is used inside of a member, an object member method. So since the method of set feet is a non-static method. So when this executes, it has access to the current object or the current instance data members. And also you can use it as for accessing methods as well. It's not just attributes. So you can say the current object's data member for feet is how you can access this data member. And then this is a common way of doing a set method for feet. You can pass it in and then set the data member. And this is also another way to overcome the shadowing where the input parameters has the same name as a data member. So this will then dereference, deconflict with the parameter name and with the data member name. And we can also use this as a way to call the constructor for a class. So if we create a constructor for stock, passing in a string, we can pass this same, we can call this and then reference a different constructor and invoke the other constructor for the same class. One more thing here is that the this method is used inside the constructor, then it must be the first statement inside of the constructor if you're going to be chaining the constructors this way. So there's now a concept of mutable and immutable classes. Some classes can be changed, which is mutable, and some classes cannot be changed, immutable. Okay. So an immutable class is a class that the data fields can only be changed at initialization. But after they're initialized, the immutable class object internally cannot be changed. So there's some benefits about having immutable objects that they're more simpler to design, easier to understand, and they are also a safe way to be used within multi-threaded applications. So this is the guideline for creating a immutable class, that the class should have the final keyword in the class header, and that every data member within the class should have a private and final that basically prevents the internal data members from being changed. And if there are internal objects, like the aggregation concept, if there are internal objects that are mutable, that when you have any kind of method that uses that, or let's say wants to pass the actual object itself to the caller, then you need to make a deep copy of that object and then pass a copy of that, just create a deep copy version as the return type or the return value on that method. So another thing about the keyword final and with immutable objects is that whenever you have a variable definition where you use final, once it gets initialized, they cannot be changed. So here, you can see here that when we declare this variable name myCell, and we use the constructor to create an object with it, that if later after this three lines, we attempt to reset or change to like a myCell equals to another object, the Java compiler will stop and point out a syntax error that you cannot reset or reassign this myCell to another variable. So again, this is about having an immutable class that contains aggregate objects that are mutable, so that if you ever write methods where you would return a reference to that mutable object, that you would need to do a deep copy of that mutable object instead of passing the original object. So if your mutable class constructor accepts a reference to a mutable object as an argument, that we do not assign that reference into a field. Okay, so that's another thing we have to make sure is that you pass a mutable object reference as an argument into the constructor of your mutable class, that we do not assign that reference to any data member within our mutable object, our immutable object. Instead, what we need to do is that we need to make a copy of that mutable object and then assign a field reference to that copy. Next concept is about enumerated types. So this is a special kind of Java class. You give it a definition such as day, and then you can give it special definitions of strings that have special meanings for this kind of class definition. So this is a enum or enumerated type. So here you can say, I want to create a variable called workday, and it is of type day of enum type. And you can then set a specific value of that enum type. And these are similar kind of classes, but they also have, just like before, it passes an address to the specific value of the enum type or enum value. And the enum methods have some built-in type of operation. So the toString gives the actual string representation of that constant. The ordinal will give the order of the value. So for Thursday, it would be 4. If you go back here, Thursday would be the zero-based fourth item. So 0, 1, 2, 3, 4. And then equal you can actually use to compare various enum values to each other. And then you should use also the compare. You can give you the less than, greater than, or equal to value result of that enum type. And then the best benefit about the enum or enumerated type is that you can use them within switches, and it makes the code a lot more efficient. With garbage collection, this is an internal piece of Java, is that once objects no longer have a reference to it from a variable, that the Java garbage collection will free up that memory for you and then deallocate that memory from your program. So here's an example of where you create an object, a bank account, you set a reference to that object here in the first variable, and then here you make a second variable pointing to the same address reference. So these two variables point to the same object. And so here is a visual representation of having one object having two variables pointing to the same object. And then once you set one of the variables to null, this then releases one of the reference to the object, but there's still one more left. So the Java garbage collection will not deallocate this object quite yet. It will wait until this variable is actually set to null. And when the second variable or all the variables to the object are set to null, then Java will then go about and then deallocating this object. But we don't really know when exactly the garbage collection will come around to deallocating this object. But it will basically run the next time the garbage collection runs again in the background. One way that we can actually track it and see when these objects get deallocated, you can actually create a finalize method on the object. And when the object instance is about to be deallocated from with the garbage collection, and you put like a logging statement to, let's say, a logger, um, then you can actually determine when each one of those objects gets deallocated by the garbage collector. Okay, then the last kind of stretch concept here is about collaboration. This is about a concept of documentation where when multiple classes interact with each other, this is called class collaboration. Similar to how we had that one course that was pointing to a instructor and then a textbook. Here, this is now about stocks and stock purchase. So we have multiple objects that interact with each other, and then we will define a what we call CRC card, which documents how the multiple classes interact with each other.